So actually the first talk is me, it's not Alexander. So there's one error on the program and it is the first line. I apologize for this. I am not Alexander. If that is Alexander, I'm going to be giving the first talk. So if we, here it is. The purpose of my talk is to give a very simple overview of the kind of things that you will be hearing from other people today. So I'm going to start with some very simple messages for people who are not already specialists in this subject. The first point is that earthquakes happen on faults. Earthquakes happen when rocks slide or break and move past each other on surfaces we call faults. Here is an example from outside Los Angeles. Can we turn the lights down? This is a picture taken outside Los Angeles in California, and what you are looking at on this picture is a river. So here's a river, and you can see it meets this line, and then the river jumps to the side and continues. That line, this red line, is the famous San Andreas Fault in California. You are looking at this river, which has moved sideways by 8 meters in an earthquake in 1857. This fault, this surface, is about 300 kilometers long, and it goes down into the earth about 15 kilometers, and it is the vibrations as the rocks move past each other on this fault that creates the shaking in the earthquake. This movement is horizontal, but the movement may also be vertical. Here is another fault from an earthquake in New Zealand where the motion is mostly vertical. When the rocks break along the fault, they are also bending. So a lot happens away from the fault, and this is an important point which we will use later. So this cartoon shows a fault where the motion will be horizontal. And now I will show you a cartoon with lines which cross the fault, and you will see as the fault is locked by friction, the rocks on the side will bend, and the bending is shown by the color. So as the amount of bending increases, the color increases until the rocks can bend no more, and eventually they break. And when they break, like this, is the earthquake. That is the movement in the earthquake. The earthquake starts at a place which we call the epicenter, and the rupture, the earthquake moves along the fault. The movement moves in that direction along the fault. So what's happened at the fault is that the rocks have become unbent, but they are still bent over here. So here the rocks are still bent, here they are unbent, and this tells you that something is happening also away from the fault. And this is something we can use, and other people talking about later will show you how we use it. So when you see the final result, this is another picture from California. Here is the fault, and you can see the lines which have moved. In this picture, it is difficult to show that also there is bending away from the fault. But there is bending over a distance of about 10 kilometers, so that becomes important. Another important message is that the movement on the fault in a single earthquake is not very much. Here's an example from Greece. This is the movement on the fault, which is about 1 meter. So the movement in the fault in the earthquake is not very much, but the earthquakes repeat again and again and again on the same fault. And so they make a bigger surface. So this is a surface which results from many earthquakes on the same fault. If we stand back, this even bigger surface here shows the result of about 50 earthquakes on the same fault, and this picture is taken at the base of this mountain in Greece, and this is the fault surface. The entire mountain is created by repeated movement on those faults. So the faults make the landscape. And one of the points of this conference, several people will talk about if we learn how to understand the landscape, we can read in the landscape the signals which tell us about earthquakes. So there is information in the landscape about the earthquake behavior. So that is very important, and we will be hearing more about that later. So if we look at a map of earthquakes in the world, the main questions we need to ask then, geologically, are where are these faults, how do we find them, and how do they move? What is the characteristics of the movement on these faults in the earthquakes? This is a map of earthquakes in the world. So the red circles are earthquakes, And a map of earthquakes is therefore a map of faults that are moving. Each earthquake represents a fault, and we need to find out about those faults. Now, one of the things you can see immediately from this picture is that in the oceans, the earthquakes occur in very narrow zones here. These red lines in the oceans are where earthquakes concentrate. Those red lines in the oceans are plate boundaries. Those are the boundaries of the tectonic plates. They're shown here in yellow, and it is very easy to show where they are in the oceans. But you can also see that in Asia here, the situation is very different. The earthquakes do not fall on narrow lines. In Asia, what we see is mountains. We see very high regions here in Central Asia and nearby flat regions in Kazakhstan and Siberia and here in India. So this is where the earthquakes occur, and this map of the earthquake shows the earthquakes are mostly associated with the high mountains in Asia here and not the flat regions. So this is one important difference between the oceans and the continents. In the continents, in the oceans here, it makes sense to talk about a plate boundary because the earthquakes are local to a very, very narrow place. But on the continents, it makes no sense to talk about plate boundaries. There are no plate boundaries, there are no lines where the earthquakes concentrate. The earthquakes are over a very wide region, and so there are many, many faults to look for in the continents. So the continent problem is more difficult because there are many more faults, and they are spread over very wide regions. Now, the reason we have so many earthquakes in this part of Asia is because of the movement between India and Asia over geological time. This is a map of the world 160 million years ago. At that time, India, which is yellow, was here. It was next to Africa and next to Antarctica and Australia. And you will see in the next pictures, I will show you as the time moves forward, India moves northwards to collide with Asia. So here we are at 120 million years. India has separated from the southern continents. It moves north at 80 million years, 60, 40, and this is the situation today. So these maps are real maps. These are not artistic impressions. These we can make these maps. And the important feature of this collision is that it is not like a car crash. It has not stopped. It continues at about 40 millimeters per year. So India is moving north into Asia at 4 centimeters per year since the collision 50 million years ago. So this is an important point. What we see now, then, is the mountains and the earthquakes which are caused by the northward movement of India continuing today at 40 millimeters a year. We can measure this movement today with GPS. So this shows a modern GPS instrument. It is measuring very accurately the position on the ground, and we can measure how this position changes with time. What does it look like? It looks like this. This is a map where each arrow shows the movement of a point on the ground relative to Siberia here. So Siberia, there is no movement. It shows India moving north at 40 millimeters per year, and you can see all these arrows show the movement in the Himalaya, in Tibet, and here in the Tian Shan in Central Asia. This is Kazakhstan here. This is the movement which has continued for 50 million years, and so the total movement of India northwards into Asia is 2,000 kilometers. So India has pushed into Asia by 2,000 kilometers over the last 50 million years. And that is why we have the mountains, and that is why the earthquakes continue today. So let us look a bit more closely at this region here. So if we look at this region here of the Tian Shan, this map shows the earthquakes here. This is Almaty is here. The blue stars are big historical earthquakes since 1900. This is the earthquake in 1911. Here, if we look a bit more at the movement from the GPS, this shows the movement, and these arrows are about 20 millimeters per year. So the south side here in China, in the Tarim Basin here, is moving to the north about 20 millimeters a year. This is almost half the movement between India and Siberia. So half of that movement happens here in the Tian Shan, which is why the mountains exist and which is why there are so many earthquakes there. If we look more closely at this region here, you can see the picture rather better. So these are all measurements with GPS in the field. These arrows here are about 20 millimeters per year, and here you can see they are nearly zero. So the Tian Shan are being squashed, pushed together by about 20 millimeters per year. So that movement happens in earthquakes. That movement happens because faults move, and so we need to understand where the faults are responsible for those earthquakes. This is a modern map produced by Richard Walker showing the main faults in this part of Central Asia. Here is Almaty. The black lines show the major faults which are responsible for earthquakes, which we know about. Right, this is not a complete job yet. This research is continuing, but this is what a modern map looks like of the faults which produce earthquakes. This is the result of a lot of field work by Richard and his colleagues from Kazakhstan and Kyrgyzstan in this region over the last 5 years. This is a more detailed map from other people in Kyrgyzstan. So here is Bishkek. The lines show the major faults and other structures which are capable of making big earthquakes in Kyrgyzstan. The numbers here show the rate at which these faults move over geological time. So here's a number 2, that means 2 millimeters per year on average, right? So over geological time, it moves on average 2 millimeters per year. When this moves in an earthquake, it will move several meters, right? But the average rate is about 2 millimeters per year. And remember, the total rate across here is about 20 millimeters per year. So each fault is only doing a small part of the total job. So this is the kind of understanding we need more of in this part of the world. Here's another map to show you in Iran. This is also produced by Richard Walker and his colleagues, and it shows a lot of red lines in Iran. This is the capital, Tehran, and these are faults which we know have moved in earthquakes in the past. So there is a lot of work to do to produce this kind of map, but this work is absolutely essential for a modern assessment of earthquake hazard. Without these maps, you really cannot say where the earthquakes are going to happen and what will be their characteristics. So this is a very important thing to do. I want to show you another feature of this situation. If you look at the collision between India and Asia, you will notice the earthquakes are in the high mountains, and India is relatively flat, and there are a few earthquakes, and central Kazakhstan is relatively flat, and there are a few earthquakes. There is a big contrast here. It is interesting that India collides with Asia, and India is fine. India is almost undamaged. And Asia has big mountains and lots of earthquakes. So there is a very big geological contrast between India and Asia. What is responsible for that contrast? Because this is very important. That contrast is related to the geological age. This is a map of geological age in the world, and these dark colors, red here, purple, which you see here, these are old rocks. And India is made of very old, cold rocks, and that is why it is strong. So when India has collided with Asia, it is less damaged than Asia because it is stronger and colder. Now this is important. Let's look at this a bit more closely. So here in red are the very old rocks of the world, and you can see like Arabia, India, here, Africa, Siberia. These are the places where there are few earthquakes because the rocks are very old and cold. That is one feature. The other feature which is important, which you will hear today, is that the thickness of the tectonic plates on the continent is very variable. It changes a lot. So here is a map of Asia, and this, which is the same region, the colors show the thickness of the plate, which is called the lithosphere. And generally, these colors are pink. in general, the thickness of the lithosphere or plate is about 100 kilometers. But the blue colors are much thicker. Where it is blue in two regions, one is under the high mountains of Tibet and the Tian Shan. It can be as much as 200 or more. It is also thicker under the old rocks of India here. This is the peninsula of India, where it is thicker, and also here in central Kazakhstan. So let's have a look at that. This is again showing the variation in the thickness of the lithosphere. The blue colors show plate which is more thick than normal. In yellow we have Kazakhstan. Kazakhstan and India are on the blue colors where the lithosphere is thicker. Because it is thicker, we have different characteristics for the earthquakes. And if I look at the earthquakes here, these symbols are the earthquakes. We have some earthquakes in India here, and some earthquakes in central Kazakhstan, and these earthquakes can be very big. So this is another theme we will hear a little bit more about today from some of the other speakers, that when you are away from the mountains, you still have some earthquakes, and they can be very big. The reason they are big is because the thickness of the layer which has the earthquakes is a bit more than usual. This is an example from India. Here is a section from India from the southwest to the northeast. That is this section here. And I'm showing you the earthquakes associated with 2001 earthquake. This was a big earthquake in Gujarat here. And the reason I'm showing you is that these red symbols are the aftershocks for this earthquake, and they go down to 45 kilometers here. That is much deeper than normal. In most places on the continents, the earthquakes stop at about 15 or 20 kilometers. In this part of India, the earthquakes go much deeper, and for that reason, the faults are bigger, and because the faults are bigger, we can get bigger earthquakes. So this is a very important feature of these regions next to the high mountains. It is the region we have two very large earthquakes in North India in 2001 and 1897 here. These are not under the mountains, they are next to the mountains, but they are very big. Now this is a situation which exists also in Kazakhstan. Here are do not worry about the symbols, but the colors are important. The red colors are earthquakes which are deeper than 30 kilometers. The number here shows the depth. So this earthquake at 40 kilometers in Jungaria is in front of the mountains here. This shows that in this region of Kazakhstan, we also have a thick layer for the earthquakes, and we expect to see some big faults in this region. And there will be a talk this afternoon which shows a very big fault in this region which moved in a big earthquake in the past. So we have two problems. We have earthquakes in the mountains, but we have also earthquakes next to the mountains, which can be an important part of the earthquake hazard. What we see here is the flat region of Kazakhstan adjacent to the mountains. It is exactly the same situation in India, adjacent to Nepal and Tibet. What happens in India is that India, the cold, strong rocks of India, slide underneath the mountains like this of Tibet and Nepal here. The surface between the two is this surface here, which is a fault. And that fault, when it moves in big earthquakes, like the earthquake last year in Kathmandu in 2015. So this is what happens in those faults, and there is a similar situation in Almaty. This was a cartoon. It was an animation, which isn't going to work. Never mind. Where that fault comes to the surface here is the front of the range. This is the edge of the mountains here, and that line is shown on this map here by this yellow line. So this yellow line is the fault which comes to the surface, so India can slide underneath the mountains of the Himalaya and Tibet. This fault has produced many big earthquakes in the past. Most recently, the earthquake in Nepal last year, but also 10 years ago in Kashmir in Pakistan, there was a big earthquake here. If we look at this region a little more detail over the centuries, all these dates here are the dates of really big earthquakes in the past. So the 2015 earthquake last year in Nepal is just here, but it is in a region where we have had big earthquakes in the past. So this is very densely populated. These are the main cities in India. So that is why the threat here is so important. Many places are in the same situation. So here is Almaty, which is on the edge of the high mountains here, of the Zaleski Altai here, the Tian Shan. This is Tehran in Iran. Again, the red lines are the faults. And here is Bishkek in Kyrgyzstan, again, at the edge of the mountains. These are all places which have been damaged in earthquakes in the past here, and that is the situation they are in today. The final point I want to make is associated with where people live. This is a map of the earthquakes in Asia, and in black are the main historic trade routes. These are the main trade routes linking the east and the west across Asia here. If I remove the earthquakes, you will see that the trade routes follow the main geological boundaries. The trade routes follow the edges of the deserts, the edges of the high mountains, the edges of the plateaus like Tibet, the high region of Tibet. And these features are all created by movement on faults in earthquakes. So that is where the cities have developed, and that is where people have been killed. These symbols show earthquakes which have killed more than 10,000 people in red, or more than 100,000 people in yellow, over the last 1,000 years. And you will see they are concentrated along the trade routes because that is where people lived. So people live in cities on the trade routes, but the trade routes are localized by the geology, so the populations concentrate in the dangerous places. So that is a major feature of Asia. Many of these cities are now much bigger. So many of these places which killed 10,000 people in the past are now cities of many millions of people, right? Because people have concentrated in the dangerous places. This picture shows every 100 years, for the last 1,000 years, how many people have died in earthquakes. And these show the earthquakes which have killed more than 10,000 people, or in red, more than 50,000 people. For a long time, there was only one of these earthquakes, maybe every 20 years. And when the population started to increase, we had one of these earthquakes maybe every 5 years. If we just look at the present century, we have many earthquakes already. We are only 16 years into this century. We have had many of these big earthquakes. And of course, this is because most of these earthquakes are in Asia, let me say, right? This is, of course, related to the growth in the population. But it is more than that. It is also because the population has grown, concentrated in the dangerous places because of the geology, and those places are where the earthquakes occur, right? So this is what we are faced with in Asia. So places in the past which were damaged, which did not have many people, now have many millions of people, and they're in places where there have been earthquakes in the past. And Almaty is a good example of this, but also Tehran, Kathmandu, Tabriz, Bishkek, Ashgabat. These are all in the same situation. My final slide just shows a little bit the context of this meeting. The people who have been invited here to speak from outside Kazakhstan are all part of this project called Earthquakes Without Frontiers. The project is really about trying to do something about this situation to help. This shows in color the most vulnerable people, the people at greatest risk here in this region. And there are 5 main regions we are interested in here. And these are the countries which are involved. And we have people from each of these regions at this meeting today. The purpose of this project is to bring people together, so that the earthquakes in parts of China are very similar to earthquakes in parts of Italy and Greece, and we can learn from talking to each other. The earthquakes you will hear in Iran are very similar to earthquakes here in Kazakhstan and Kyrgyzstan, and so there are similar lessons to be learned. So one of the things about this, one of the aspects of this partnership is to try and help each other, to share experiences, to try and help train young people to exchange information, data, methods, techniques by talking to each other. So this is a project which has run for nearly 5 years now, and that is the main purpose, is to try and have scientists in these countries working together to help each other. And that is the background to this meeting. So I will stop there. we have time for a few questions if there are any questions, but I'll now hand over to the chairman. Thank you.